right? Okay, so we will start now today the remaining part of the NumPy tutorial, and we will quickly finish this off. And the target is to quickly move on to the image processing section, right? So we'll start now and discuss about the uh, remaining part of the NumPy, right? So we last time we got the introduction to modules, as well as we discussed about NumPy, and we discussed about NumPy arrays and how to create a NumPy array, as well as how to convert the existing Python list to an NumPy array. So these are the things that we discussed last time. And thereafter, we discussed about two attributes available in NumPy: the shape as well as the ending, right? The number of dimensions. So shape simply gives you like how many rows and how many columns, and I mean the dimension details, right? So the dimensions gives by the shape, and as well as ending gives like how many dimensions are there, right? So that's what it says, right? And yeah, so then we discuss about NumPy arrange as well as NumPy resize, right? Sorry, reshape, right? And yeah, so thereafter we move on to a topic called array creation routing and routings. And here we discuss how to create an empty array, and how to create an array with zeros, how to create arrays with ones, right? And we discuss about them. And thereafter, this is where we stop, like indexing and slicing, right? Indexing and slicing. So this is the topic that we are going to discuss today, and simply like cover this content, the remaining part of the indexing and slicing, right? And under indexing slicing, we discussed few things: the random integer, how to create a array with random integers, right, for a given set of values, right, given range of values, right? So 0 and 100. So this simply creates a array with 10 rows and 5 columns, and the range of values lies between 0 and 100, right? So that's what we have done here. And uh, right, got it, right? So then I wanted to show you a few things. Now here I have created two random arrays, you can see, right? np.random.random integer, and for 3, that means 4 rows and 3 columns, and values lies between 0 and 100. So that's the array 1, as well as array 2, right? So we have created two arrays, and here I add these two arrays and get the addition of, I add these two arrays and get the addition to array 3. That's what we have done. So let us run this and see what happens, right? Okay, so here I wanted to show you how arrays are added in NumPy, right? How we can add arrays in NumPy, right? So here you can see, okay, array 1. This is the array 1. And this is the array 2 with some random values, right? And I add them up, right? So I add them together, right? And this is what you are going to get as array 3. So how the addition is done? Can someone like identify that how the addition is done? Can you like identify uh, the method of addition here? Method they have used for the addition? Yes. So this is the array 1, and this is the array 2, and this is the resultant array, like the addition of those array 1 and array 2. Yes.
We are just simply summing up the elements at same element,
Yes, exactly. So
same index.
yeah, so element wise addition, right? So this element 1 1, sorry, 0 0 is added 0 0 of this one, and this is the addition of array 3, and this element with this one added here, right? So this is element wise addition, right? So when you are going to add two arrays, the element wise addition will be done, right? 41, 85, 126, right? So then like we can conclude, if you add two NumPy arrays, element wise addition will be done, right? That means like you need to have equal arrays like in dimensions, right? So dimension should be equal, right? For example, if you make like, let's say, okay, 5, 4, see, that cannot be added, right? So therefore the shapes should be equal in order to add, right? So it should be two arrays. In order to add them, they should be in the same shape. That's one requirement, right? And here you can see like the same thing, but I have performed the multiplication, right? So if you perform the multiplication, the same thing happens, right? Same thing in the sense what? Here the elements wise multiplication is done. Can you see, right? The element wise multiplication, isn't it? Right? Element wise multiplication. Then you may be wondering, right? Okay, like there's another method, right, to multiply arrays, the dot product. So this is kind of a cross product, right? I'll show you that. But here, this is how the array, if you multiply using this multiplication operator, if you use the multiplication operator, elements wise multiplication is done. And here we have an array, and I divide the array by 10. Right? Actually, this makes no sense, but in Numpy, this means like 10 is a scalar. So what happens? The scalar division. That means what? So this is the array 1, right? This is the array 1, some values with some random values. And if you like divide it by 10, what happens? Each and every value individually divided by 10. Right? Each and every value individually divided by 10. Got it? Right? Understood. That means if you like add, subtract, multiply, or divide an array from a scalar, right? If you do that operation, what happens? The array, like element wise operation is done, right? So it's done to all the individual values, right? Now, I wanted to show you, that's why I'm taking some random values, right? I take two random arrays and add them, right? So just I wanted to like show the how the addition and everything is done here. That's why, right? Okay. Got it? Okay, then so this is not only for the addition. If you add something, that's the same, right? Here. So scale addition. See, 10 is added to all the individual elements. 7, 17, 82 becomes 92 likewise. Got it? So if you like perform anything with a scalar, right? So scalar multiplication and scalar addition or whatever the scalar operation will be done. Got it? And this is how we are going to like provide the dot product, right? If you have two arrays, let's say array 1 and array 2, and I print those arrays, and this is how we are going to use like matmul, numpy.matmul. That means the mathematical multiplication, sorry, matrix multiplication function available in Numpy. So you pass two arrays and it gives you array 4 or array 3, let's say. So this is now the element wise, I mean the, sorry, not element wise, the dot product, right? You know how this is done, right? Do you know how this multiplication is done? Huh? Right. So row wise and column wise, right? Yeah. So this is the dot product, matrix multiplication. But if you use this one, this is element wise multiplication, the star mark. But here it's a matmul, that means a dot product, right? Okay. So then let me create another array, right? So like this, okay, another array like with 5 rows and 7 columns, 5 rows and 7 columns. Now you can get the max, right? Max. What it gives by max? The maximum value of the whole array, right? the maximum value of the whole array. And np.max, what we have to do? Okay, np.max, you have to pass the array, right? So this gives you the maximum of this array, right? Maximum of this array. And argmax, this gives what? Argmax, any idea? So argmax gives where this 99 is located, right? So it's like this: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 23, right? So it says, okay, the maximum value is located at the 23rd value of the array. Got it? The index of the maximum value. The index of the maximum value is given here. Understood? Right? The index of the maximum value. Right? Then, like you can see, if you pass the array to the max, it gives the global maximum. Global maximum in the sense like the maximum of this array. Right? The maximum of this array. And what you can do here, right? You can pass another parameter like this here: np.maximum axis 0. What it mean by axis 0, right? So you know that two axes are there. So this is axis 0, and this is axis 1. Right? So if you provide, if you run this code, right? So what this gives you? Huh? So it simply says, okay, go row wise, sorry, column wise, right? Axis 0, go along axis 0, right? It says go along axis 0. 0, 1, 2, 3, 4, 5, 6. So we have 7 columns, right? So what happens? It go through each and every column and get the maximum of each column, right? See, 95 is the maximum of the column 0, and 72 is the maximum of column 1, and here 99. Got it? So likewise, it will like go along the axis 0, right? It goes along through the axis 0 and gives you the maximum of each column. Maximum of each column. And this is like not only for maximum, you can get several other things as well, right? So this is quite similar for the minimum. You can get the minimum, right? Got it? You can get the summation. So what happens? Column wise summation, right? Column wise summation. Column wise values are added. Or else you can get the mean. So this is the mean of each and every column, right? So this means the mean of this is the mean of this one, this column, and this is the mean of the first column. Likewise, this gives you the column wise minimum. Oh, sorry, mean, column wise mean. Right? Okay. Now what happens? Any idea? Okay. So I change the axis into axis 1. So any idea on what this gives here? Yes. Yes, so this simply goes through rows, right? Row wise maximum. That means what? Huh? This row maximum is 86. Right, and this row maximum is 98. This row maximum is 95. This row maximum is 99. This row maximum is 91. Got it? So row wise maximum is taken, right? If you want to get the row wise maximum, right? And this is how we are going to do that, right? So mean and everything can be done, right? So I will show you one last thing, right? What this argmax gives then? Right? So argmax along axis 0. So this is axis 0, right? 0, sorry, let me use another color. 0, 1, 2, 3, 4, 5, 6. So any idea what argmax gives when you give axis? Yes? Any idea? What this gives you? Okay, let's see. All right, so let's see. Row number of maximum. Yes, exactly the same, right? So it gets the maximum value, all right? No doubt it gets the maximum value. Okay, this is the maximum value of this one, and this is the maximum value of this one, maximum value of this one, right? So argmax give the okay, row wise maximum and axis, I mean row wise maximum, but argmax gives the column number where the maximum value is located, which row the maximum value is located. So 2, okay, the first column maximum value is in the second row, first column maximum value is in the fourth row, the column number 2, the maximum value is in the third row, right? Column 3, the maximum value is in row 1, right? Understood? Got it? So that's what it gives by the argmax. Right? Okay. Yes.
Excuse me, sir.
Yeah. Yes.
So, if axis is equal to 1, what would be the?
Yes.
I
So,
mean, what is of axis equal to here?
sorry, I couldn't hear you. Yes. If the which one equals to 1?
I mean, what if axis equal to 1? Yes. What is the sense of that argument?
This one, like this.
What is this equal to? Yes.
Okay. So this means, right? So it goes through axis 1, right? It goes through axis 1, this one, right? Okay. So it's going to get the maximum value from this axis. Okay. So the maximum value here is 86, 92, 98, so 98, 95, right? And it gives you where the maximum value is located in column, right? So like this, okay. Row 0, the maximum value is in column 0, 1, and 2, right? See? Then you are going to go to this row. Okay, this is the maximum value and it's in the column number 3. See? And this row, if you take the maximum value, it's here. So that's in the column number 2. See? Got it? And the last,
okay.
yeah. So last one is, sorry, 91. This is the maximum value of the third column. I mean, yeah, this column, right? So it's like the column number is 5. Right. So yeah. Then one last thing, right? One last thing before concluding NumPy, right? Before concluding NumPy, right. So this is slicing, very indexing very interesting topic, right? So before running this, now this is, I have an array, right? So I want to talk about now indexing and slicing, right? So one important thing, okay. So what this means, any idea? If you print array 2, 3, what it means? Yes? This is something you know, right? Right. So it simply says what? Row 2, column 3. So if you run it, right? Okay, column number 2, this one, and row number 3, this one. So it should print 45, right? So let's see. So very simple, right? Very simple indexing, right? Very simple indexing. Column number 3, sorry, row number 2, column number 3, right? Then what this means? 0 to 2, 0 to 4. Now, anyway, what you have to identify, this is very interesting thing in NumPy, slicing. So this comma simply like separates the axis. Okay, so then this is about rows. Okay, after the comma, so this comma separates the axis. So this is about X and this is about Y, or this is about rows and this is about columns, right? This is about rows and this is about columns. So what it means, okay, row wise, since it's before the comma, okay, so this is row, something to do with rows. So it asks us to go with like row wise, go to 0 to 2, right? Row wise 0 to 2, okay. 0 to 2, that means 0 to 1, you know the upper limit is less than 1, right? I mean 1 less than the given value, right? So 0 to 1 is simply 0, 1. Okay, so row wise 0 column and first column. Sorry, row wise, first row and 0 row and first row, column number 0 and column number 1. And column wise 0 to 4, column wise 0 to 4, okay, column wise 0 to 4, that means 0 to 3, right? So now can you see there's a highlighted section, right? There's a highlighted section, right? So this is what you are going to get here. Highlighted by both rows and columns. See? Got it? Right? Right? Okay, then what this means? Colon, only the colon. That means the starting value or the ending value is not mentioned. Then what it means? Huh? Yes? We have done these things in the first day. Yes, quickly. Yes, yes, yes. Yes, so it says all rows, right? All rows, right? The starting value and the ending value is not mentioned. That means all rows. So all rows, okay. And column wise, what you are asked to do? Column wise, 0 to 4. Then, okay, 0 to 3. Right? Right? Sorry. Matrix size rows. Oh, yeah, exactly. Right? See? So what's highlighted here, you can see it here, right? Okay. Right. So then what this gives? So read it. What? Row wise, all rows. All rows. Column wise, what? Huh? Column wise, yes. Column wise, what? Yes. Yes, column wise. Column number 4. That means what? Right? So then what will be printed? Yes, any idea? Only the 4th row, right? Only the 4th row. So see how you can simply slice the 2D or any kind of array, right? So you can slice a multi-dimension array as you want, right? So column range, sorry, row range and column range separated by a comma. You can give any range you like, right? Okay, so let me ask you a question. Okay, so can someone tell me which needed to be, like, what is the slicing that needed to be used to print this one? Yes, quickly. Yes, row wise. Quickly. Row wise. Yeah. Yes, quickly. Okay, so getting answers. Let's see. Right. So, okay. Okay. Yes, exactly. 2 to 5, 3 to 8. 2 to 5, 3 to 8. Yeah. Or else 2 to n, 3 to 8. Exactly. Both are correct. Right. Right. Okay. Good. Okay. So there is a small exercise. Right. So there's a small exercise to be completed. Right. So what we are trying to do here, I will show you. Now, from the things that we have covered up to now, we are going to do this. Right. From the things that we have covered up to now, we are going to do it. Right. Um, so we have a CSV file like this. Right. We have a CSV file like this, and it contains the name, math, physics, chemistry of a student. Right. Of a student. And then what you have here is simply there are math, physics, chemistry marks, right? Math, physics, chemistry marks. So marks of 3 subjects, and you have the right? You have the you have these details, right? So the objective of this exercise is to read this Excel file, right? Read this Excel file using Numpy. The objective is to output this file, right? Is to output this file. So what I mean by output this file? Simply calculate each one's grade, right? Each student's, each subject grade, right? So if you take John, his maths, physics, chemistry grade, and finally the average in the sense like the average of these 3 values, right? So a practical example of from the things that we have discussed up to now, right? From the things that we have discussed up to now. So we want to do this and create this file, right? We want to create this file finally. That's the tutorial that you are going to get, right? A simple tutorial, right?
Excuse me, sir.
Yes.
Hello.
Yes.
Sorry to interrupt. That one thing to one maths and arguments. You plain again.
Yeah. Sorry, I couldn't hear you. Yes. I had like max and argmax. Yes.
Yes, the 17th.
Yeah.
Yes, 17th script.
This one.
Yes.
So you want me to explain it again? Is it?
Yes.
Okay.
Both the steps. Yes. 17 and 9.
This one, right? Okay. So this is what happens now. We get
Yes.
the maximum, right? Maximum of the array. But now this one, it simply gives you the maximum of the whole array. That means a global maximum, right? So what happens here, like we have provided another parameter. We have provided another parameter called axis, right? We have provided another parameter called axis. And in this case, we have 2 axes. So this is the axis number 1. That means x-axis will be taken as the axis 1. And this will be taken as the axis 2. Right? Y-axis will be the axis 2. Right? So it's like this, axis 0 and axis 1. Right? um, yeah. So what happens now here, if you like provide axis 1, we will go through the axis 1. We will go along the axis 1, right? Axis 1 in the sense like it's rows, right? So we will go through each and every row. We will go through each and every row like this. So we have like 0 to 4. So we will go through each and every row here. Right, so what we do here is that we like for each row we get the maximum. So this one 86. So you can see the first value is 86. Then we get 98. Okay, so the second value is the second row value 98. And the third row we have like, okay, 95. The maximum value is 95. And this one, the maximum value is 99, right? And this one, maximum value is 91, right? So it goes through along the axis 1 and get the maximum of each row, right? So similarly, if you provide like axis 0, it will go through columns, right? So if you like do it like this, axis 0, let's say. So it now goes along the axis 0, right? And get column, each column, right? So it's go through like each column. Right? It goes through each column and give you the maximum, right? So here, 94.
Okay.
Yeah, right.
Okay, got it. So for a two-dimensional array, we have zeros, and for a three-dimensional array, you have to equal to also.
Yeah. Yeah. So what was the question? Like how to do it? How to do it in 3D array? Is it?
No, I'm guessing like for a 3D axis equal to 2 for the 2's there.
Actually, I can't hear you clearly. I think something with the internet issue. I can't hear you clearly. Sorry, I can't clearly hear you. Can you try once more time?
I'm chatting. I'm sending through chat.
Okay, sure. All right. So, yeah. Yeah. So for 2D, there will be axis 1 and axis 2, right? There will be axis 1 and axis 2. Yeah, exactly. Now, for example, let me show you. Right? So let me show you something here. Right. So what this means, let me like make it a bit small. So what this means, right? 4, 3, 2. Now the thing is, like it shows like a 2D, but it's not 2D, it's 3D actually, right? So we have 3 axes, like I mean, this is the x-axis and y-axis and z-axis, right? So what it means, so this is actually like this, see, 13, 75, 38, 74, 17, and 98. Right. So this is one thing, right? So it's what this means. Okay. So here it says, okay, sorry. Right. So what this means. Right. So this is like this, right? So 3 and 2, right? 3 and 2. So what we have here is we have yeah, sorry. So 4, 3, right? So 4, 3 in the sense, okay, 4 rows and 2, 3 columns. Four rows and 3 columns. Right. So yeah, here I'm give me a second to check this. Okay. 4, 3. Yeah. So now if you take an array like this, give me a second, right? Give me a second. Okay. So let's say Numpy array dimensions, right? So let's say, yeah. Okay, this is a very good example, right? Right. Right. So I think now it can be, we can discuss it from here, right? If you have like this kind of array, 4, 3, and 2, right? 4, 3, and 2, what it means. So it has, okay, axis 0, Yeah, give me a second. Right. Okay, so I made a small mistake here. Right, I made a small mistake here. This is axis 0 and this should be axis 1. Right? So it's a mistake done by me. So this is axis 0 and this is axis 1. Right? Got it? So this is axis 0 and this is axis 1. Right? So what it means simply, right? So what it means simply here is that, right? So if you, not this one, but if you take another one like, yeah, here, right? So now this is axis 1 and this is considered as axis 0, right? Rows will be axis 0, columns are axis 1, right? So what it means, okay, so here what we have asked to do here is to get the maximum of axis 0, right? So what it does, right? Yeah, what I explained is correct, but the method I explained is wrong, right? So you can see axis 0 is this one, right? So what happens, it go through like this. This is the axis 0, right? So you can see the axis 0. So it goes through like in this direction and calculate the, right? Like this direction, the direction of axis 0 and calculate the value of each column, right? So if you put like axis 1 here, that means what? It goes in this direction. So you can see the direction of the axis, right? So it goes in that direction. So axis 1 direction is this one, right? Axis 1 is in this direction. So what happens? If you put axis 1, it goes in this direction and get the row wise maximum, right? So this, like here what we provide is the direction, right? So if you put axis 0, that means, okay, go in axis 0 direction, right? Like this, right? This direction. Got it, right? So here also, now a small mistake there, right? So here also in this example, what it means, right? So this is 3, 2, right? So 3, 2 in the sense, okay. So 2 rows and 3 columns, right? So if you create an array like this, 4, 3, 2. So what it means 4, 3, 2? What it means by 4, 3, 2? Right? You can see 4, 3, 2, right? Okay, 4 in this direction in y-axis, right? And 3 in this direction, that means the x-axis, and 2 in z direction, right? Got it? Okay, so can someone tell me, if I take np.max, of the array, let's say axis 0, what you are going to get? So you have to go in the axis 0 direction. Yes, what are the values you are going to get? Any idea?
7939.
Okay, 7, 9, 3, and 9. Not exactly. The thing is that you have another, right? Here, can you see now? Okay. Right. Actually, it cannot be like cannot be given here, since like we have 24 values, but we have only few visible values. Right here we have only few visible values. So let me check whether there is all visible values. Okay, I think no, this also not visible. No. Here I wanted to show you that there are 4 into 3 like 12, and 12 into 2 24 values, right? So there are 24 values, but you can see only what? You can see only like 12, and here you have another 1, 2, 3, like, so we have 12 here, and we have 1, 2, 3, 4, 5, 6, 7, 8. 4 into 3, 12, 12 into yeah. So can you see, like, we can visible, we have only visible how many values? Like, okay, there we have 12 here, and 1, 2, 3, 4 here, and again 1, 2. See, these are the only visible values, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And you can see this is same, right? These 3 values are the same, and these 2 values are the same. These 2 values are the same, and these 2 values are the same, and this is also the same, right? So we can't see all the values here, right? Some of the values are hidden, so we can't exactly say, but let us try it here whether I can see it. Four, 3, 2. No, it's not also visible here. 4, 3, 2. So 4 columns, 3, 4 in Y, 3 in X, and 2 in Z. Anyway, let's see.
దిల్సున్నారు లేడా మీ చైతన్యపురి కాలే
All right, so yeah, axis 0, 46. Yeah, thing is, we can't visualize this 3D arrays. That's the only issue. Otherwise, I can show you these values, but unfortunately, it's not visible. Cannot be visualized. Is there any method to show this to you? Anyway, right? So I will tell you, right? So if you want to get the maximum of axis 0, right? This axis. So then you have to get the maximum of this one and this one and this one, right? So here you can see that you are going to get, okay, 0, this one and this one. So these will be the maximum. But can you see that there is another set of values here, right? So you have to get the maximum of those values as well, right? Got it? So we are going to get how many values here? We are going to get like 2 set of values, 999, and also this column you have to get the right. You have to get the maximum of these 3 as well, right? So if you go along axis 2, that means you have to get the value of this one, this one, this one, and then this one, this one, this one, and this one, this one, this one, and this one, this one, this one, right? So there will be like what, 3 into 4 values, 12 values if you go through axis 3, right? So it's a bit confusing. Now what I will do, I will come up with like, actually I can't explain with this this without a clear diagram. That's the case. So let me prepare a diagram for you, and I will actually go through that and show you how to take a maximum and everything in a, when you have a 3D array, right? When you have a 3D array, how to take the maximum and everything. So let me show you that. I'll create a kind of a right. I will create a kind of yeah. Okay, so I will create a kind of a figure and show you how this 3D is done, since I can't, without having all the values, I can't actually explain it to you here, right? But anyway, like make it comfortable with 2D for now, right? Make it comfortable with 2D for now, but I will explain you how to get these things in 3D as well, right? Okay, right. So right. Okay. But anyway, but I think that we can, I can explain it here as well, right? So can you see now earlier? Yeah. So if you take this one like this, what this means, right? Number of rows and number of columns, right? So that means this is, if you take this one, right? So if you take this one, this is, you know that this is what? This is y-axis, right? This is y-axis, right? And this is x-axis, isn't it? Right? So 5 is in y direction, right? And this is in x direction. Got it? Right? Understood? You know that this is the x and y, right? So usually x is the horizontal axis and y is the vertical axis. You know this, right? X and y. So this is in y direction and 10 is in x direction. You know these things, right? So if you go here, now what this means. So again, okay. So this is x and this is y, right? So x 10 columns, y 5 rows, right? Got it? So here, what this means, the same thing but bit different here. X, y, and z. right? X, Y, and Z, right? Got it? So actually this is something like this. Now if you take this kind of a rectangle, right? So it's like this. We have how many? We have 3 rows and we have 2 columns, right? X and Y. So X direction 3, sorry, Y direction you have 3 and X direction you have 2. Understood, right? So we have what? 4 of them. Got it? So 3, 2 and 4 of them. Got it, right? 4 of them. Understood? So for example, I mean, it's shown in 2D, but this is what here, and this is what here, and this is this one, and this one is this. Got it? So that's like what? 2 into 3, right? 2 into 3, right? We have 2 into 3 2D matrix, and we have like 4 of them, right? We have 4 of them. Understood? Got it? So that's what it means. It's not XYZ, but it's XYZ, right? ZYX, right? It is ZYX. It's ZYX. Got it? Got it? Understood, right? So here now, okay, so if you understood that one, can someone tell me what you are going to get here? Can you provide me the values that will be printed here quickly? Yes, quickly, right? Give me the answer quickly and give me a second as well. I'll be back in 1 minute. Sorry. Please provide the answer in the meantime. Right. So we have one answer. Yes, exactly. Right. Yes, that's the answer. Yes, very good. Right. So that's the answer. Right. So how it's done? Simply now, what you want to highlight here is that we have to think it like this, right? So it's here. This is what you are going to find here. And let's say this is what you are going to find in the next one. Right. So what I have done, right? So you know that simply this is X, Y, and Z, right? So you know that this is X, Y, and Z, right? So sorry. Z, Y, and X. So you know that this is the X-axis, right? And sorry, yeah, I mean, this is the X-axis, X, and this is the Y-axis, right? And this is the Z-axis, right? So what I have like, okay, Z0, what do you mean by Z0? Huh? What do you mean by Z0? Okay, so that means what? This one, right? Z0, can you see? Now, this is where Z is 0. Let me like, okay, so this is here 0, this is Z1, this is Z2, and this is Z3, right? And this is what? This is X, yeah, this is X1 and X2. And this is Y1, Y2, and Y3. Got it? Right. So a bit difficult to understand, but that's what it means, right? So anyway, now what this means. I'm not going to ask any more questions. Yes. So here, can someone tell me what this means and what are the values that you are going to get? Now this is a bit confusing, but I think you can answer.
13, 10, 12, 46.
Okay, let's see. 13, 10, 12, 46. Okay. Others, what do you think? I think I'm not sure, but I think I'm also not sure. It's a bit confusing, but I think this is what it means, right? Isn't it? Let's see. Yeah. See? Right. So the X row, so get the X row, right? Get the X1, right? Get the X, right? So it means like, okay, right? See? So X of everyone, X of each, right? So X of each is, okay, we have X axis here and here also we have x, here also we have x, here also x, we have x. So you are asked to get all the x, right? Got it? This one, this one, this one, and this one, right? Bit confusing now. I know that this has been bit confusing. So yeah, exactly. So this is what you have got, isn't it? Right? This is very hard to explain. I mean, hard to explain without any kind of a proper graph, right? So I'll try to find something tomorrow and I will explain it in detail tomorrow, right? So don't worry about this, right? Okay. So about the exercise 1, now I'm not going to discuss it now, but I have a pre-recorded video of this one, right? I have a pre-recorded video for this tutorial. So I will provide you this one, right? So this simply explains about what? How to simply get this kind of, sorry, not this, but right. So the exercise is about this, how to read this kind of data set, right? And using Numpy, how to convert it to this form, right? How to calculate the grades of each student for each subject and how to calculate the average. So actually the code is already given. The code is already given here. The code is there, but I'll give you the explanation video, right? I will provide you the explanation video of this tutorial, but you can try this out and try to understand yourself. Tonight, after the lecture ends, I'll share the explanation video of this one, right? The explanation video of this one with you, right? How to do this using Numpy, got it? Right. Okay, so now, yeah. So now we are going to start the Matplotlib tutorial. So the video explanation of the exercise 1 will be provided to you, right? Today itself, so you can go through that and give me, yeah. I will ask the coordinator to send it to you, right? Right. Right. Okay. So okay. So now again, you will please try this code, right, and try to understand. But the explanation of this exercise, how it's done, you will get a video, right? An explanation video done by me about how this exercise is done will be provided to you, so you can refer it and understand how, I mean, what are the things done here, right? So I'm not going to take time in the class to do this, but I will provide you a video pre-recorded video of the working method, or I mean the solving method of this exercise, right? Okay, so then let me quickly move on to the Matplotlib tutorial, and I'm going to discuss about Matplotlib. So Matplotlib, you know, the Python library, the open source Python library, one of the best Python libraries available for visualization purposes, right? So graphing purposes, right? So if you want to plot a graph, it can be a line graph, it can be a pie chart, it can be a bar graph, it can be a scatter diagram, it can be a histogram, it can be a 3D graph, anything, right? So you can plot it using Matplotlib. So very useful. Now, if you are wondering why, okay, we need to plot graphs. Now, tomorrow on, I mean, today itself and also tomorrow, we are going to discuss about machine learning, image processing, right? And when you are going to deal with them, we basically deal with data, right? We basically deal with data sets, right? And data, Excel files, images. So we have like always see the behavior of some data sets, right? We have to see the behavior, characteristics, right? The distribution of data sets. So plotting them and plotting and getting a visual feedback is the best thing that you can like do before analyzing data, right? So data should be plotted, data should be visualized. So for that purpose, Matplotlib provide you lots of functions in order to like plot graphs, right? So very handy tool to use, right? That's why we are discussing about Matplotlib. Matplotlib library is a very useful library in Python. This is for visualization purposes. So we can say to plot graphs, right? Okay. So we will simply see how we can draw a simple graph in Matplotlib, right? So this is how I mean you can plot a graph. Usually you have to provide x and y, right? X first, then y. Set of x values, right? Set of x values and set of y values. And what you have to import is from matplotlib.pyplot as plt, right? Or else you can do it like this as well. Right? From matplotlib, import pyplot as plt. Or else you can do it like this. Import pyplot, import matplotlib.pyplot as plt. This, both are the same, right? So here from Matplotlib library, we are importing the sub library called pyplot as plt. That's what we do here, right? So pyplot is the plotting library, the plotting library available in Matplotlib, right? So we use this pyplot for like drawing various kind of graphs, right? So plt, in plt now here Matplotlib, there is a sub module, Matplotlib module, there is a sub module called pyplot. We import that. So in pyplot we have several functions. Now here plot. So plot, what it simply does is it plots a line graph. So plot is for line graphs. So we provide set of x and y, and it draws set of x1. I mean, according to those x and y, it draw this kind of a graph, and you can write. You can finally, after plotting it, in order to visualize it, you have to put plt.show, right? So this is how we are going to plot it, plt.plot, and you have to pass set of x values and set of y values, and finally plt.show. So it creates you a simple graph, right? And we have several kind of graphs available in Matplotlib, right? So another type is scatter, right? Scatter. So scatter is like a scatter diagram, you know, right? So here, like, you can provide only x values as well, right? So if you provide x values, the sorry, you can provide only y values, right? So if you provide only y values, what happens? It takes x values as like 0, 1, 2, 3. Likewise, it going to take x values as default values, 0, 1, 2, 3, 4, right? So that's what happens. But if you have like several x and y values, like let's say, okay, this, right? Then you have to provide both x and y. See, like the default one is x and y, but if your x is 0, 1, 2, 3 default, you can provide only y values and draw it, right? So anyway, this is a scatter diagram, right? Yeah. Right. So let me create some values and let me show you the formatting of the Matplotlib library. So let me first create set of x values. So I'm going to draw two graphs and show you how we can format this graph, right? So this is how we are going to create x values. I mean, sample x values. X equal np.arrange 0 to 100 by 2. So you know what happens in np.arrange, right? So we did this last time. So we create some x values and then I create two y's, right? Y1 equal 2x into 3 and x equal np power dot x square, right? So np power x2, that means x square, right? So it gives you two y values, y1 and y2. So you can see, you know how the scaling is done, right? Now it's scalar multiplication and scalar addition. So for each and every value is multiplied by 2 and 3 is added. So you can see this is the resultant value. These are the resultant values, right? Each of the value here is multiplied by 2 and 3 is added, right? 0 into 2 plus 3, 3. 0 into like 2 into 2 plus 3, 7. 4 into 2 plus 3 is 11 likewise, right? And y2 is simply x squared. So individually x is squared, right? Likewise. Got it? So that's how it's done. So now if you run this and I can plot the two graphs in the same, right? Got it? Right? So yeah, so you can see this kind of a graph, simple graph, right? So I plot two graphs in the same, two curves in the same graph, right? Got it? So x versus y1, where y1 equal 2x plus 3, and x versus y2, where y2 equals np dot power x comma 2, right? And ple dot show, right? So we can format this. I mean, formatting in the sense you can provide a custom color as the third parameter. See? So red and green. So you can see x and y1 is red, x and y2 is green now. See? Right? So the second parameter will be the color. And so if you are wondering what are these colors, see, blue, green, red, cyan, magenta, yellow, black, white. So these are the colors you can right, like this, right? B, G, R, C, M, right? Likewise. Right. So these colors are available. So you can provide the kind of directly you can provide the this character. So if you see here, it will be cyan color, right? Cyan. See, and also you can, I mean, still you can use hexa values as well. It's fine. I think hexa values will work here. Let's see. I'm not sure, but yeah. So you can use hexa colors as well. But simply you can use a character and do it like this as well. Got it? And with this color, you can provide the next character as the line type. The second character you are going to provide will be taken as the line type. See? So this is double dash, and this is like plus, cross, anything you can use. See? Or like this, anything, right? So Matplotlib markers, let's see. So you can see these are the markers available. So lots of markers available, right? For example, if you use like O, let's say O, CO. So first character always will be the color. The second character will be the line type, right? Line type. And also you can provide a legend, a label. And here also I'm going to provide a label. Right? But if you run this, nothing will happen. See? Nothing will happen. Right? Nothing happens here. Right? So what you need to do here is that you have to provide, okay, plt dot what? Legend. You have to turn on the legend. Then only you are going to see it. See? The legend. The key of the graph, right? And also you can provide a title as well. PLT, no, the X value, sorry, the X label. X label simply X values, let me put X values. And let me put a Y label as well. PLT dot Y label. Y values, let's say. See? The X label and the Y label, right? The axis name, right? Axis name. Then also you can put a title, PLT dot title. See the title. And also finally what you can do is simply you can save this into a physical file, pld.savefig. Right. So then if you check your working location, you can see the graph is saved to a physical file, right? But it's a bit low resolution. There's another parameter called DPI. So DPI determine the resolution. So you can like 300, 400, 500, 600, 200, 100. You can provide several DPI values. So DPI, you can change the resolution. Now, if you run with the DPI 300, it will be a like a high resolution graph, right? High resolution. It's in high resolution. So when you are going to increase the DPI, that increase the resolution, right? So if you put 500 something, right? So this is, you can see like, right? So it's very high resolution. See? See? Very high resolution. So you can change the resolution now. If you like, the thing is, if you want to put a graph using Python into a report, let's say your report, your thesis, some of the reports, so then you can use a handy tool, this pyplot or Matplotlib is a handy tool to use that. So if you want to get a physical file, a PNG file, then this is how we are going to save it. Okay. And yeah, right. And yes, so you can get plot subgraphs in the same graph. Here you can see. So we have 3 graphs in the same graph. I mean the same figure. Sorry, not the graph, but same figure. You have 4 graphs. So this is, in this example, I'm going to explain you how you can simply plot subgraphs in a same figure, right? Same figure. So this is how we are going to do now. We have set of x and y values. You can see x values are set of names like 0, I mean group A, group B, and group C, and values are 10, I mean 1, 10, and 100. So so first, if you are going to create a subplot, right, subgraphs in the same figure, you have to create a figure, pld.figure fig size. You have to give the fig size. Fig size, now this is given in inches, 10 inches and 5, right? So this is the, I mean, the height, and 5 is the width, right? Sorry, not the height and width, sorry. The width and the height, right? 10 is the width and 5 is the height in inches, right? So you have to first create a figure. If you want to create a subplots, first create a figure. I just create a figure. So width and height. Width and height to be provided in inches, right? So this is the height in inches, and this is the, width in inches and height in inches, right? So 10, 5. So then this is how we are going to create a subplot. So I have created like 4 subplots, right? So here we give a number. Can you see, right? 1, 4, 1, right? And here 1, 4, 2, and 1, 4, 3, 1, 4, 4, right? What this means, right? So now this is how we are going to create. Now here, these are the 4 subplots. First one is a bar graph, right? PL.bar. Second one is a scatter diagram, as you can see. Third one is a line graph, PL.plots, line graph. And fourth one is also a plot, but with different markers, right? With different markers. So now this subplot, this number actually decide or define the place where your subplot will be, placed. This decide where your subplot will be placed, and how we are going to do.
Excuse me, sir.
Yes.
Sir, I had a small doubt. While plotting plt.plot, for example, plt.plot names, comma values,
Yes.
will it take within itself? Will it assign itself like that? For example, for x value 1, it will be assigned in itself to value group A, or both will be separately plotted. In values 1, 10, comma 100 are there, and in names group A, comma group B, comma group C are there.
Yes.
So for value 1, so for x equal to 1, y is group A. For x equal to 10, y is group B.
No. Actually, this
Like that, will
is
it be
x and this
implemented?
is y, right?
Yes.
Right.
Then for a group A, the y for group A y is 1, and for group B y equal to 10.
Yeah.
Like that, will it be?
According to the order, yes.
So if there is any extra value in x or y,
No, it won't
then
work.
it will be
It gives you
won't
an
work.
error,
Okay.
right? So let's see. I mean, we can do it and see.
Yeah, sure.
So the question was, okay, what happens if you have this kind of a thing, right?
Yes.
See, you are getting an error. It says shape mismatch.
Yes.
Objects cannot be
For each x value or y value, there should be another x or y
yeah.
value.
So you have if you have n x values, you have to have n y values as well,
Okay.
right? So now, I mean, this can be something like, okay, 1, 2, 3, like this. Also, you can. So it can be a number then, right?
Yeah. Yes, I got understood.
Yeah. Also, you can use a string. It's fine. Got it? Right. Okay. So then, what I wanted to explain, okay, 1 for 1. Now we have 4 subplots, right? 4 subplots, and this is what actually defines the place where your plot, right, is going to be placed, right? So 1 for 1, these first two characters, or first two digits, right? First two digits will be same for all the subplots. You can see first two digits are same for all the subplots, right? So 1 4 means it has 1 row and 4 columns. 1 row and 4 columns. The whole figure 1 4 means it has one row and 4 columns, right? So it's the number of rows and number of columns. So it's common for all the subplots, right? And the last or the third digit decide the place actually, right? The third decides the place, right? So it's like this now. This says, okay, in the subplot, the first one will be this one, first one. And the second one will be scatter diagram. Third one will be this one. Fourth one will be this one. So it's going to place like this. See? It's going to place it like this. So it start from here and go like this. Right? So 1, 2, 3, and 4. So if you have 2 rows, this is what happens. It goes this direction and comes here and go this direction. Right? So anyway, it goes in this direction. Right? So if you have a new row, right? So for example, shall we plot it like this? Then you will understand. Right? Shall we plot it like this, 4 diagrams like this, right? So then how many rows and how many columns? Yes. How many rows and how many columns? Yes. 2 rows and 2 columns, right? So then 2, 2. See? So how the numbering is given, right? How the numbering is given, okay. 1, 2, 3, sorry. Right? Got it. Right? Understood. Right? So that's how the numbering is given, right? Got it? Right? Okay, so that's how we are going to plot subplots in Matplotlib, right? Okay, Yeah. So a similar thing is also given, right? So 2, 1, 1, 2, 1, 2. So that means 2 rows, 1 column, 2 rows, 2 rows, 1 column, and this is the number 1 plot, and this is the number 2 plot. Right. Right. Okay. Yeah, we have a question. Let's see. What keep dimensions means? Keep dims. Yeah, keep dims. Where you found that keep dims?
Actually, I came through that word in deep learning
Okay.
in the last week while practicing some of those like neural network something.
Okay, keep dims.
It was like keep dims equal to true or false, like that it is there in the np dot array of keep dims equal to true, like that it is there.
Okay, I'm not aware about that. Sorry. If you can show me, I mean, if you can send me the source, I can look into that, but I'm not aware about that.
Yeah, okay, if it's fine, you just keep continuing. If I get it, I will.
Okay, right. Okay. So now, yeah, this is how we are going to actually, you can annotate, right? So there's a function called annotate, and you can put text like this. So the first parameter will be the text, and then the x and y. X and y simply where you need to like point this arrow into, right? So point this arrow into, so you can see 2, 1 is 2, 1. So the point of the arrow, right? The arrow points that point, right? And xy text is where the text should be placed, right? So let's say a max value. So 3 in 1, 5. So this is where the text placed, right? And arrow tip, you can provide the arrow tip, and simply the color can be given. The color of the arrow tip can be given in name, and shrink simply defines. So if we can change this one, so this, so you can see it shrink the arrow. That's what it happens. So you can provide the number to define the arrow size, right? Got it? Okay. So I think these are the only things that I want to like discuss about this annotating and everything, right? But we have lots of functions can be drawn, like pie charts, bar graph, scatter diagrams. I'm not going to discuss about everything, but I think that you have a good knowledge now and you can go through them yourself. And the histogram, we can draw histograms using Matplotlib as well, and we can even we can create 3D graphs as well in Python. I mean, Matplotlib, it's a very advanced library. So this histogram drawing will be covered in the tutorial, the Numpy tutorial. I ask you to like, I provide the exercise answer to the exercise. So that covers how to draw histogram as well. So you can get it from there, right? Got it? Okay, so any question from this section that we have covered up to now? Quickly, if you have anything. Okay, so I think now we are going to move on to quickly to the image processing section, right? So I think you have these files with you, right? You have these files with you, this folder. Not all, but I think this is not required convolution of an image. Other than that, do you have these files with you? Yeah, sure. You will get it as soon as I actually yeah. So you will get it within 30-40 minutes. So I asked the coordinator to send it to you, right? So you will get it soon, right? The tutorial. Right. So do you have this file with you, folder? We have all the materials with you. Yes. This samples folder like this and everything. Do you have it with you? Okay, great, right? So now let me go. Now here you have a samples folder. Now the samples folder contains some images and videos, right? Some images and videos as well, right? And other than that, it creates this kind of a plant folder, right? Where you can see some images of the plants, right? And yeah. So so let me go to that. Right. So now we are going to start a very interesting topic today, right? A very interesting topic, right? Image processing. Um, give me a second. Okay, so we will discuss about image processing now, right? So what do you mean by image processing, right? Image processing. So if you are going to do something with images, right? So if you are going to process some image and do something, right? If you are going to process images and do something like this, okay. For example, here we have example, right? We are going to discuss several examples in our workshop, right? Right. So this is the image processing task. See. Right. Okay. So we process this image, right? We process this image, and what we do is we detect the height of this plant, right? So this is one example of image processing, right? So we process this image into like this format, and finally we detect the height of this plant, right? So without measuring it physically, right? Without measuring it physically, you can take an image and you can measure the height of it. So we say this kind of application, image processing, application related to image processing. What we are going to do, we are going to process some image and get some details from that image. Understood, right? So that's what you mean by image processing, simply. All right. Okay. So now right. Right. Okay. So before going on to image processing, let's try to understand what is the image, right? What is the image? Before going on to image processing, let's understand the image, right? So an image in a computer, or image, your usual image in a computer, we are going to see this kind of pixels, right? We are going to see this kind of pixels, but we can get a visual feedback from that. What I mean by a visual feedback, okay, we can identify, okay, there is the eye, there is a there's the mouth, there's ears, there's the hair, right? And this is a human. So we can identify several features and then we say, okay, this is an image. This is an image of a human, right? This is an image of a person, right? So we can simply say that, right? But when it comes to computers, computers can't see anything like, but it can see only something like this, right? This is what the computer can see. Computer can see a set of values, right? In a matrix form, set of values, right? It can see only set of values, right? What do you mean by that? What do you mean by that? I mean, it makes no sense for, I mean, it makes now, let's say you can't see these three. You can't, I mean, you can't see these two. Right? Okay. So now if I show you this, can you see what is there? Huh? Can you see? No, you can't, you can understand, right? So these are the pixel values, the values of the pixel. I mean, these are the color values, right? The color values of the image. You are not going to see anything there. You will see just a set of numbers, but actually computer sees these numbers, right? Computer sees these numbers. Computers can't see this kind of a thing, right? What computers see is that thing, right? But for us, these color values, right? These color values, it makes sense for us. Okay, okay, this is eyes, right? So we can always get a visual feedback. But the computers, no, they can't. They just see set of numbers, right? So in a computer, an image can be defined as a 2D matrix, right? 2D matrix. And single element of this 2D matrix is known as a pixel. And a single pixel contains a color, right? A single pixel contains a single color, and that color is known as the pixel value, and it is a number, right? So what computer sees is the pixel values as numbers. It's not going to see colors, but it will see these set of values as numbers, right? These set of values as numbers. Got it? Right? So we see nice image, but computer sees, right, set of numbers. Understood? So computer sees a 2D array with set of numbers, right? Okay, let me ask you a question. Additional question not related to this content, right? So can you identify this object? What is this? Is it a human? Huh? Is it a human? So if it is a human, can you identify who is there? Any idea? Yes, exactly, right? So this is Abraham Lincoln, right? So this is Abraham Lincoln, and see, so you have to appreciate your visual cortex or your whole visual system. Why? Now I can count the number of pixels here. It's a very low resolution image, right? So there are like 500 pixels can be there, or 300 pixels, right? But still you can, from those 300 pixels, you can still understand that this is, you can still identify that this is Abraham Lincoln, right? So that means our visual system is very powerful, right? It has like 500 million training data, years of training data, right? So our genes takes it, right? Our genes carries it. So our visuals, right? So we can identify even, I mean, lots of objects in the world, right? So our visual system is very powerful. Anyway, this is Abraham Lincoln, but see, with a very low resolution image, even you can identify it, right? Got it? Even neural networks can do this. Right? Neural networks also can do this. Machine learning can also do this, right? Okay, so then we'll discuss about in detail about images. So before going on to image processing, we will first discuss about images, right, in detail. So there are three main types of images available in computers, right? Three main types. What I mean by main, we have some other types of images as well. We have some other types of images as well, like the transparent images, right? But mainly we take, okay, we have three main types, but other than this, we have some other images types as well. So those are color, gray, and black and white, right? Or we say color, gray, and binary images, right? Color images, gray images, and binary images, right? So three main types. So how we are going to identify whether it's a color or a black image or a black and white image or a gray image is by considering a pixel, right? So an image is a 2D array, right? So we are now familiar with 2D arrays, right? So 2D arrays have, right, okay, rows and columns, right? So if you take this pixel, it can be identified as 0, 2, right? 0, 2. Now we are familiar with arrays. We are familiar with multi-dimensional arrays now. So an image is simply an array, right? Image is simply an array, right? Therefore, if you take this pixel, right? So that pixel can be identified as, okay, 0, 2, 0 row, first two, second column. So it's 0, 2, image 0, 2, right? So if you take that pixel, if it is a color image, right? If it is a color image, that pixel has three components, right? In color images, a single pixel has three components and they are known as BGR or RGB, right? BGR or RGB components, right? Now, sometimes all the color images are not having BGR. Some of them are HSV format is there and YUV format is there. So there are lots of color image types, but simply there are three components. In a color images, we have three components, right? For example, BGR or RGB, right? Why I say like BGR without saying RGB, since OpenCV has the form BGR, not RGB, right? In in uh, uh, in OpenCV, the color order is BGR, not RGB, right? So anyway, when you kind of define an image, if it is a color image, a single pixel has three values BGR, and to be exact, those are 8-bit numbers, most of the cases. Those are 8-bit numbers. What I mean by 8-bit numbers is that it has three 8-bit numbers, right? So for B component, one 8-bit number, for G component, one 8-bit number, for R component, one 8-bit number. So three 8-bit numbers. So the range of 8-bit number, any idea? What's the range of 8-bit number? What's the minimum and the maximum value you can represent using a 8-bit number? Yes? So it is 0 to 255, right? Yes, exactly. 0 to 255, right? It's 0 to 255. So that means we have we have three 0 to 255 values, right? For example, now you know the order is BGR, right? So if you like have 25500, that means pure blue. Since blue becomes 255, that means the maximum, right? 0 to 255, a 8-bit number can be between 0 to 255. So if it is 255, that means the maximum, right? So BGR, so if B is 255 and other components are 0 and 0, so it's the pure blue, right? So similarly, if B is 0, G is 255 and R is 0, that becomes green, right? So if you have now, I think you can't see that value, but anyway, this is having like 0, 255 and 255, right? So this is now, you know, from your right, grade grade 2, grade 3 knowledge, G and R, right? So if you combine POG and POR, you are going to get yellow, right? Yellow. So that's what shows here, right? And 0, 0, 0, that means like theoretically empty, right? 0, 0, 0. So that means black, right? And white, the full color, right? The full color, the perfect color, right? 255, 255, T255. So theoretically it says, like if you can take pure blue, pure red and pure green, and if you mix in equal proportions, you are going to get the white color, right? So that's why 255, 255, 255 becomes white. Got it? So you can have intermediate values like this, 180, 120, and 60, right? So we have lots of VGR. See? See? This kind of a value, right? So that's what I mean. Got it? Okay. Right. So that's about color images. So color images, a single pixel contain 3 values. Those are BGR, and BGR like mixed together in order to create colors, right? So BGR mixed together. So there are like infinite, not infinite, but infinite many colors in the world, right? So it can be created using BGR components, right? So in a color image, a single pixel represents 3 values, BGR components. Then a gray image, if you take a gray image, now this is a gray image, this is not black and white. But sometimes we refer this as a black and white, right? No, it's a gray scale image. So in a gray scale image, what you are going to find is a single 8-bit number, right? A single 8-bit number. A single 8-bit number, one 8-bit number. That means there is a value which can vary in between 0 to 255. So in a grayscale image, 0 represents black, 255 represents white, and anything in between represents a grayscale value, right? It simply represents a gray value. Got it? And the last one is binary. What I mean by binary is that if you take a binary image, binary can only have either black, either white, either black or white, right? So binary image can contain either black or white. So 0 represents black and 1 represents white. So that's what it says, a binary, 0 or 1 image. Got it? Understood? So that's what you call a binary image, right? Understood? Right. So that's it. Now, shall we now import OpenCV and try to first, before doing image processing, right? So before doing image processing, before doing something to the image, what we have to do is we have to get the image, right? So we have to get the image to our code, right? So that's what we are going to do now. So it can be done using the OpenCV library. So OpenCV library, how we are going to open the OpenCV library, import CV2. This is how we are going to open the OpenCV library. And the other thing that you have to, you can install the OpenCV is not coming as an inbuilt library. So you have to install it. You can do it like this, pip install OpenCV, OpenCV-Python. Right, so this is how we are going to install the OpenCV. So before using OpenCV, you have to install it, right? And it can be done simply like this, pip install OpenCV-Python. So this installs OpenCV in your computer. And the other thing is that The other thing is that CV2, now you may be wondering why it's it's not importing as OpenCV. So this is the convention. I mean, this is the standard. It says CV2, right? It says CV2. So what do you mean by OpenCV? OpenCV refers to Open Computer Vision, right? Open Computer Vision. So the best open source library available for computer vision and image processing, right? So anyway, CV2, this is how we are going to load the OpenCV module, import CV2. Then thereafter, you can load a image by giving the path like this. Okay. Now cvd.imread. So cvd.imread is the command that we use to load the image into our computer. Right? Got it? So now cvd.imread samples flower.jpg. What it means? Now this is where my code located. Right? This is where my code located. And related to this point, now always we have to provide the path relative to where our code is, right? So our code is here now. Relative to this point, go to samples and get this flower.jpg. That's what it says, right? So samples flower.jpg, right? So that's how we are going to load the image. And sorry, I have done a few other things here as well, right? So after loading the image, you can show it in a window, right? You can show it in a window. So what do you mean by imshow? Imread is the function that we use to load the image, right? And imshow is the function that we are going to show the image. And this live, what this live means? This live means when you run the command imshow, it creates a new window. It creates a small window. This live will be the window name, and this image is the image that you are going to show in that window, right? For example, if you run this, you are going to get this kind of a thing, right? See, live. So this is the window name as I mentioned here, right? So window name, got it? Right? The window name. And this is the image shown, right? Got it? And what the wait key does, so it waits zero in the sense infinite time. So like waits key 0 simply refers like wait forever, right? It asks to wait forever. Wait key 0 asks to wait forever, right? And then cvd.destroy all windows. That means what? So this wait key 0 is simply like we asked to wait forever. So this show this window and wait forever, right? Wait forever. And after that, right? After this waiting ends, what happens? Ask to destroy all the windows. So it's like this now. It waits forever until we press a key. That's what it says like wait key, right? So it waits until a key is pressed. That's what it does. So 0 refers to like wait infinite time, right? So now if you press any key, it destroy this, it like goes here and destroy all the windows. Destroy all the windows is like the windows opened by OpenCV. Now this is a window opened by OpenCV. So now this is the code running. So it shows the image and it waits until the key is pressed. What's the time that's going to wait? 0. That means infinite many time, right? Wait forever. Now what happens if you press the key, right? When you press the key here, then this destroy all the windows, right? Sorry, we are okay, right? So now what happens? You can like provide the value in milliseconds here, right? So now what this means, 5,000 milliseconds. Now what happens? This will be there and it will be there for 5 seconds and terminated. See, waits for 5 seconds, and then destroy all the windows. See, got it? And what you can do now, the important thing, it waits 5 seconds, and as I mentioned, it terminates, right? But if you like meantime, if you press a key, it always terminates, right? It's like it waits for a key. I mean, it waits to be, I mean, to a key to be pressed 5 seconds. But meantime, if you press a key, it also destroy all the windows. But after 5 seconds, it definitely destroy all windows. Destroy all windows in the sense like the windows opened by OpenCV, right? And the other thing, now this is how we are going to provide the relative path, but you can provide the absolute path as well. So what we are going to do with the absolute path is get the path here, right? Path where you want to load your image. Okay, this is the path, and in this path we have this flower.jpg, right? So what I do here, I get it. The path is pasted here, and okay, flower.jpg, right? But there is one thing. If you run this, I don't think that this will work. Yeah, this won't work, right? This won't work. Since what you have to do is you have to manually chain these slashes into other side. So it's right. Right. It's not going to work, right? So is it like we need to do it always? But therefore now if you chain this to this manually, and if you now run this, now it won't give you an error. It loads it, right? So that means if you give the absolute path, you have to like chain these things to other side. But without doing that, you can do it as well. So keep it like this. Now you know that this gives you an error, right? But you can put the R here, simply R, a regular expression. You can put R here, right? So when you put R here, no issue. It reads it, right? So no need to change it manually to this side. What you can do is you can, instead of doing that, you can put R. That's the same thing, right? Got it? So this is how we are going to load the image, right? So let me use 0 here, and yeah, so you can see we can press a key and we can destroy that window, right? And let me show something. Image 100. Okay. Okay. So any idea what this prints here? Yes, quickly. Anyone? What is that? You have 3 values. What is that?
Maybe height or width of that image.
This one?
I think this one.
No. Yes, exactly. So you know the image is a 2D array, isn't it? Right? A 2-dimensional array, right? A 2-dimensional array. So what we are going to do, like, okay, image 100. So what it gives you? So this is a 2D array. So this is the pixel value of the 100 and 100 elements here, see? So you know that this is a 2D array. So 100 and 100, this is the pixel value of that. Right? That's the pixel value. I'm using Google Colab and I can't open the image. Yeah. So in OpenCV, I mean, sorry, the Google Colab, you can't, I think you can't use the imshow, but instead of that, what you can do, so if you are using Google Colab, you can do something like this, see? you can get the PLT, and instead of using imshow and yeah, you can use plt.imshow. The same thing happens, right? Right. There's a small issue with the color. The thing is, now the color you are going to see it a kind of a blue color. The issue is now we use the plt.imshow. There's an imshow function available in Matplotlib as well. So what happens, this color conversion, now the imshow takes the image as RGB format, right? It takes the image in RGB format, but OpenCV works with BGR. So that's why this color is changed. So blue is changed to red. That's the only issue, but other than that, it's right? It's working. Can we check total size of the picture? Yes, exactly. You can do that. See, print, right? So can you now, another thing I forgot to mention. Now, this image is loaded as a Numpy array. That's the most interesting thing, right? So you are familiar with Numpy, right? So this is a Numpy array. OpenCV use Numpy arrays. OpenCV images are Numpy arrays, right? So do we have any method of getting the number of rows and columns in a Numpy array? Yes, exactly. Right? See, that's why I told you Numpy arrays are used everywhere. See. So any idea what this means? 360, 483. What this means? $460 rows and 361 columns. The height and the width. Height and the width of the image. See, height and the width of the image. Then what's 3? Height and width, okay, 3. What that means? Each pixel has 3 values, right? This is what it means. Each pixel has 3 values. So this is not a 2-dimensional array, it's actually a 3D array. Since like each element, if you take each pixel, there is 3 values, BGR, right? For example, this is the BGR value available in where? Right? Where? The 100 and 100 element, right? Okay. So let me do something like this. So can you explain what I'm doing here quickly? What I do here? Yeah, changing to white. Which one I'm changing to white? Yes. So what has happened? Huh? Yes. Any idea? See, 100 pixel. We can't exactly see that, but anyway, try to do that. 100 pixel here. Small, tiny little element is now white. Can you see? So we have now manually what we have done. Huh? See, all the array operations we have done, we can do it here as well. So can someone tell me what I'm trying to do here? Yes. What I'm trying to do here? The indexing and slicing. Can you remember indexing and slicing? Yes. If you can, please tell me what I'm trying to do here. Quickly, quickly. Yes, exactly. So we get like 100 row and all the columns, right? Yes. See? Right? So the row, right? The 100th row become white, right? Not white always, but now yellow, right? See? Got it? Right? Okay. Yeah. Then the next thing, so we know now how to load images into our code, right? So we know now how to load images into our code. Now the next thing that we are going to cover is how to load the video into our code, right? So let's see. Before loading a video, right? So before loading a video, what you have to do is you have to define the video source, right? So in OpenCV, we can read image. I mean, we can load videos with physical files available in our computer, or the webcam of your computer, or a USB camera. That means, I mean, webcam. I mean, the default webcam, if you are using a laptop, it can be done with your default webcam of your laptop, as well as USB cameras attached to your computer, or else you can get a video feed from a Wi-Fi camera. Wi-Fi camera is like CCTV camera, right? That kind of cameras you can use, right? So you can use webcam, the default webcam of your computer, USB webcams of your connected to your computer. You can load videos from video files in your computer. You can load like videos from Wi-Fi cameras or CCTV cameras, right? So if you want to load the video, first you have to do like you have to define the source. What's the source that you are going to use? Is it a webcam? Is it a physical file? Is it a Wi-Fi camera? You have to provide the source, right? So source, in order to provide the source, we have a function called video capture, right? OpenCV cv2.video capture. This is the function that we have, cv2.video capture. So what you have to do is you have to provide what's the video source that you are going to use, right? You have to provide what the video source that you are going to use, right? So how we are going to do that is by doing it like this: samples face video. So this is how we are going to load the physical file. Now I have given the path here. So in the samples folder, I have a I have a video called face video. So this is how we are going to load a video from a physical file of your computer, right? Or else what you can do, I don't have a camera, I have a desktop here, so I don't have a web camera, but you can do it. You can put 0 here. So if you put 0, then what happens? Frame will be, I mean, the video will be loaded from your webcam, the default webcam of your computer. I mean, the PC or the laptop, right? Then if you have other than your webcam, right? Other than your webcam, if you have other web cameras, right? Other than your default web camera in your laptop, if you have other USB cameras, then other USB cameras, let's say you have another video camera, that will be 1. If you have both default webcam and another webcam, USB connected webcam, that would be 1. And if you have, let's say, another webcam, 2 webcams, then the other one will become 2 likewise, right? So 0 refers to your default webcam. So if you put 0 here, the default webcam will be loaded. Got it? So I don't have a webcam here. Therefore, I use a file available in my computer, facevideo.mp4, right? So you can, like, if you can provide either the relative path or the absolute path, right? Got it? So once the source is defined, so first you have to define the source, right? You have to first define the source. Then from the source, now, one thing before, what is a video actually? You know, a video is a set of images, right? So now what you are doing in your camera, I mean the camera in your mobile phone, what you are doing by capturing a video, right? You capture images in a higher frame rate. Higher frame rate in the sense like per second you will capture like 30 frames. That's what you say, 30 FPS, 30 frames per second. So let's say that your camera in your computer, not the computer, but the mobile phone, what it's going to do when it's going to like record the video, it capture images in a higher frame rate, right? It capture images in a higher frame rate. So what happens finally, you are going to get those set of images and bundle them together. So that's what you mean by a video. So when the video is played, similarly, the frames are played in higher frame rate, right? The thing is, our eyes, right, our naked eyes, they can't identify the difference, that they can't identify that these are like single frames, right? Frames are playing one by one. No, your brain, our eyes, we can't identify that, right? But if you like have seen this Disney, right? Right? I'm not sure I'm going to find this or not. See? Right? So what happens now, if you play this set of images in higher frame rate, what happens? You are going to see that this is kind of a video, right? So this is what I was talking about. See? Right? Right? So this thing, right? See? So the frames, the higher frame rate shown in a very high frame rate, right? So that's what you call a video simply, right? Similar thing. So what we are trying to do here, now we are trying to load the single frame from our video source. It can be a camera, it can be a physical video or anything, right? So since I don't have a camera in my computer, what I do is I get a video. There's a face video, right? So from that, how we are going to get one frame is by running this code. Source is what we mean by the video source dot read. So this function, or this method to be exact, this method reads one frame from your this reads one frame from your video source, a single frame, and it gets that image into this IMG. It reads one frame and get it to this IMG. And you can see this source.read, this method returns two things, right? It returns two things. The frame is going to be there in the IMG. The frame that you are going to read will be there in the IMG. And the red simply says, red simply contains a Boolean value. That means 1 and 0, 1 or 0, true or false, right? A Boolean value. What it means, this red becomes 1, right? This red becomes 1 when the video source is available, right? And red becomes 0 when the video source is not available, right? So how become the video source not available? Your camera might be broken, right? So sometimes your camera might be blocked from the virus guard. That kind of things are there. The camera might be blocked from the Windows Defender, likewise. Those kind of issues are there. Or the camera might be not working. That's one possibility. And here also sometimes the file name, I miss some words in the file, I mean letters in the file name, and the file name not be available, right? So then the red becomes 0. So red gives you an idea whether this video source is available or not. And sometimes when the video, I mean, if you are going to read the video file continuously, once all the frames are red, right? Once all the frames are red, this red becomes 0, right? As well, right? Got it? So what we'll do, we get this image, right? And one frame, and we show it, and we wait infinite times, and after a key is pressed, we destroy all the windows. That's what we do here. So if you run this, a single frame is loaded, right? Can you see that when we print red, it says true, right? It says true. What it means? That means that video source is available, right? So if you like now change the path, now this kind of a file is not available, then the video source is not available. See, it gives you false, right? So red becomes false, red becomes false, right? And also thereafter it gives you errors since the image show, I mean the im show can't show an image since it's not able to like load the image, right? Therefore image is not shown as well. There's an error coming, right? Right. Okay. So any idea? Now this is how we are going to read one frame, right? We are going to read one frame. So how to read frames continuously? Yes, quickly tell me. Yes, a loop, right? A loop. So I told you last time, I use while loops for infinite loops, right? So while true, since we can't run a for loop here. Why? We can't run a for loop. We don't know how many frames are there in this video, right? Do you know how many frames are there in this video? No, we don't know, right? Therefore, we don't know. Therefore, what we have to do? Huh? Right. And also now this cvd.destroy window should be given outside the loop, right? And if it is 0, what happens? You are not going to see a continuous video. See? Why? One frame is shown and it's like it waits infinite time. So you have to press the key, right? So you have to press the key to pass the frame, right? Since one frame is shown, then it waits infinite time until a key is pressed. So this is not going to work, right? So what we have to do is stop it, and like 10, that means 10 milliseconds. So this delay is given in milliseconds, right? All right. See? All right. Now there's an issue, right? So can you see at the last frame, I mean, I don't know how many frames are there, but at the last frame, what has happened? Can you see? The red becomes false, right? Why? Why at the last frame the red becomes false? Now there are no more frames to be taken, right? There are no more frames to be taken from the video source. That's why this gives you false. When this gives you false, this says that it cannot be shown in the imshow, right? So what happens? This infinitely in an infinite loop, it reads frames, right? But here what happens? At the end, after all the frames are over, right, red becomes false. So this gives you an error. That means now we are running an infinite loop, right? So this is trying to load frames infinite many times, right? But after all the frames are over in the phased video, this gives you an error. So what you can do, we can break this loop, right? So can you remember we learned the break, the loop control statements, right? So we can check a condition. What if the red becomes false? So what when the red becomes false? Any idea? When the red becomes false, we break the loop. So what happens? No more errors are given. Why? It's not trying to show the image after the red becomes false, right? So after the red becomes false, this loop will be broken. Why? No more frames to be taken, right? But what happens if you haven't include this one? It's an infinite loop, and it's infinite times it's trying to read frames from the video source. But after all the frames are over, this gives you an error. Therefore, in order to, here you can see, right? So it says that image is empty, right? Image is empty, right? Image is empty, so therefore I can't show. So, but it's always trying, since it's an infinite loop. Therefore, after red becomes false, so red becomes false when all the frames are taken, all the frames are read, right? So therefore, in that case, if the red becomes false, that we can make sure then all the frames are taken. No more frames to be taken there, right? So what we do is, in that case, we break this infinite loop. Now, no any errors will be given. Right? See, now no any errors are given, right? Finally, this becomes false, and it destroys all the windows. Got it? Right? But there's a small issue here as well. What the issue? So in the meantime, you can't close it. See, if you close it, it again opens, right? See, you never close it. You can't never close it. Why? You can't close it. Why? So if you close it, since the loop is iterating, right? Since the loop is iterating, what happens? It creates another window again at the next time. Now, here we close the frame, but for the next frame, a new window is generated, right? So yeah, now array is not given here, right? Array is not given at the end. Yeah, it's fine. Now at the end, this terminates, right? This terminates, but we can't terminate it in between, right? We can't terminate it in between. Got it? So therefore, what's the solution? Now, this is the solution. Let me finish this one. Right. So this is the solution. Right? What we do is, now the wait key, if a key is pressed, we can take, we can check what's the key pressed here, right? Right. When we press a key, we can take that key. I mean, we can check what's the key pressed here, right? So if the key is 49, we can break the loop. What mean by key is 49? Now here you have to go to the ASCII values. Right? Now let me do it like this. Let me do 27, right? Let me go to the ASCII values. So 27, what's the key? Huh? I'm not saying that always use 27. No need, right? No need, but any key you can use, right? Any key in the keyboard you can use, right? So what happens here? Now, cvd.wait key, we can take a, I mean, we can take, if we are going to press a key, we can take what that key is, what the key that we pressed, right? And if that key is 27, so here we have refer the ASCII values, right? If the key is 27, I break the loop. Therefore, what happens? Now, when the code is running, if I press escape, it terminates. Why? When we press the key, it takes that key into this key, this variable key. So if it is 27, we break the loop, right? Nothing happens when we press another key, but if we press escape, it terminates, right? No need to use escape always. Like let's say, okay, T, no, let's say, yeah, 49. So what do we know? 49 is 1, right? So here 49 is 1. So what you can do is you can get 49 here as well, 49. Right? So when, nothing happens when I press any other key, but if I press 1, it terminates. Got it? Right? So now we have a code, right, which reads the I mean frames continuously. We have an infinite loop which reads the frames continuously, and once the desired key is pressed, right, but once a desired key is pressed, in the middle even you can terminate the video, right? So that's what happens there. Got it? Understood? So this is how we are going to load the video from your computer. So you can like do it for your default webcam. If you put 0 here, it loads everything from your webcam, right? So you will see a live video there, right? Okay. Right. So then I'm going to like discuss more about like simple image processing functions, right? Simple image processing functions available in OpenCV. That's few simple. Now here, what I'm going to talk about is point operations, right? Point operations. So under point operations, what do you mean by point operations? It's simply pixel-wise operations, right? So if you are going to do something like to each and every pixel. That's called a pixel wise operation. So here now, for example, when you read the image, right? When you read the image, can you remember last time what we did was we take the image, like just giving the path, right? Just giving the image path, and I read the image, right? I just give the image path and I read the image here. But you have another parameter to be passed. Another parameter to be passed. I mean, not necessary. It's a right. If you like, you can do that, right? So what 0 means, right? If you pass 0, now this is the image that I'm going to load. Sample 365, 63 when this image, right? So this is a transparent image, right? Keep that thing in the mind. This is not an ordinary image. This is a transparent image. What I mean by transparent, right? You know, right? It's a vector, right? It's a vector image, a PNG image, right? So here, so if you pass 0 and if you load it, now here what I'm trying to do here, okay, I read the image by passing 0 and I take the same image. I'm loading the same image here, right? But with three different values, 0, +1 and -1. And I take these three instances into image 1, image 2 and image 3. And I have printed the image shapes and then I have shown the images as well, right? So let's see. So this is the image 1. We will take one by one. Okay. So this is the image 1. So what happens in image 1? You have passed 0 here. Can you see? You have passed 0, right? So what 0 means, like, can you see the image shape? It says 400, 400, right? So that what it means, if you provide 0 when you are loading an image, that will be converted. What? That will be converted into a grayscale image. If you are loading a color image and if you put 0 there, it will convert it to a gray image, right? It will convert it to a gray image. Understood? So that's what happens when you put 0, right? And the other thing is, if you put +1, what +1 does, right? That means the image 2, right? The image 2, load it using 1, right? So image.shape is 100, 103. So what I mean by 100, 103? So it converts it to a color image. What it means? Okay, color image. So when you load the image, if you put 1, that image will be converted into color format. That means BGR format, right? Okay. So then what happens when you put -1? -1 simply refers unchanged. Now, -1, the image that you are going to load with -1, the same image you are going to load with the -1, when you see the shape of that image 3.shape, right? You are going to see 100, 104. What do you mean by 100, 104? So this has three components. What? B, G, R, and alpha. What do you mean by B, G, R, and alpha? Alpha is the transparency. Alpha is the transparency. So when you have a vector image, right? Vector image, like this one is a transparent image. So that's why it's loaded as a transparent image. So that's why the four components are there, right? So the transparency property is kept, but here the transparent property is removed. It converts to a big RGB image, right? So that's what you mean simply by 1, right? So this is 0, sorry, 1, 0 and -1, right? 1, 0 and -1. Got it? Okay, so that's how we are going to load the images, and you can pass, like if you want to get it directly by converting it to a grayscale image, you can do it by passing 0 here, right? Got it? Okay. Or else what you can do is you can load the image first, cv2.imread samples flower, and after leading the image, then you can convert the color. That's another method, right? So here what we have done, we take the image, like the flower image as usual, and we convert the color of this color image. So in order to convert the color of an image, we use this convert color function, right? We use this convert color function. So what this convert color function does, it gets the image, and the image will be converted into this given flag. So what this given flag, this is the color conversion flag. This is called, the second parameter is called the color conversion flag. So what I mean by the color conversion flag? So it says, okay, we apply this image into the convert color function. So what happens? This image given here will be converted according to the color flag provided here. So cv2 dot color bgr to gray. So what it does, simply it converts the color, sorry, let me simply use bgr to gray here. Okay, so color bgr to gray. So what happens, the image will be converted into this color format from bgr to gray, right? So this is the original image and this is the resultant image. After converting color, this is the resultant image. So let me show both. See, right? So this can be used to convert the color, right? So now that's not the only color conversion method. BGR to RGB. See, we have lots of color conversion methods. BGR to RGB, right? So what happens? BGR components are interchanged. See, so technically G remains the same, right? BGR to RGB, G remains the same. Okay. And we have its other color formats like HSV. So this HSV color format is quite important. This is used in the color segmentation, the next topic that we are going to discuss. Okay, let's say that we have a question. Yeah, I will finish this at 9:10, right? 9:10. Okay. Right. So YUV color format. Right? This is the YUV color format. So we have lots of color spaces available. So YUV, what's the YUV? So this is the color format used in some of the self-driving cars, right? Self-driving cars, they use this YUV color format. And do you have any idea how a color image is converted to gray? Any idea on this one? How a color image is converted to gray? Any idea? So if you go to the basics, in a color image, we have three components, B, G, and R. In a gray image, we have only 0 to 2, one component. Yes? Yes, some sort of, but not exactly. So BGR in B, if you take a color image, in a single pixel, you have what? You have 3 values, BGR, but in grayscale, you have only 1 value, right? So my question, how you are going to calculate 1 pixel from 3 values? That's what it does, right? So each pixel has 3 values in a color image. In grayscale image, only 1 value. So how? Yes, we have lots of methods, right? So one method is getting the average. Yes, exactly, one method is getting the average. get the average of the values, right? That's one method. And the other method, what? Right? Other method is like get the maximum out of BGR, maximum out of BGR, right? Plus the minimum value out of BGR, right? And divide by 2. That's another method, right? Other method is like you can provide the kind of a weight. Okay, 0.6 from B and 0.3 from G and 0.1 from blue, I mean red. Likewise, you can get a weight, give a weight. So there are lots of methods of converting this kind of a value into, right? Okay, right. Yes. So that will be everything for today, right? So I will finish it from here, right? So a few notices. So we will be covering the remaining part of this tomorrow, right? We will be covering the remaining part of the image processing tomorrow, as well as we start the machine learning section tomorrow. Very important topic. Don't miss it. And you will get the answer to the exercise 1. I mean the exercise in the Matplotlib, sorry, the Numpy exercise today itself. So you will get a video, and please go through that video. And if you have any questions, you can ask them tomorrow, right? Okay, so before winding up, any questions you may have quickly?
Sir, how to convert gray colored pic or black and white colored pic to color pic?
A good question, right? So how we can reconstruct a gray image
We,
to RGB, right?
yes.
But yeah, it's not straightforward, since I mean it is straightforward to convert RGB to BGR, but it's like 3 to 1, right? So 3 pixel values, you are going to convert it to 1, but 1 to 3, it's a bit different. So there are lots of methods available, and directly you can't do that. So there are lots of methods.
Can't we use using cv2.convert color?
Yeah, good question. I'm not sure whether it could be done or not. Is it possible? I'm not sure.
Once can you try? No.
Yeah, let me show you. Let's try and see whether it's capable of doing that as well. Yeah. So here, now let us load it as a gray image. So we will load it as a gray image. After doing that, I'm not sure whether it's going to work or not, but let's see. Gray to BGR. So I'm loading it as a gray image now, right?
Yes.
Right. I load it as a gray image since I put 0. Then I'm trying to convert that gray image to BGR and load it here. I'm not sure this is going to work. No, it's not going to work. It's not working.
Okay.
Anyway, so let me check whether is there any method available in OpenCV, right? Later, and I will let you know.
Okay, sir.
Any other questions other than that?
Nothing.
Yeah.
Use the same convert color.
Yeah, but they are using RGB. Let's see.
Okay.
No, it's not coming. Anyway, there should be a method. Let me show you. Let me try it and let you know.
Okay. We can discuss that tomorrow, sir.
Yeah, sure. So I will let you know. I just like I just wait for any other questions, and meantime I watch any. Is there any possibility? Yeah. So any other questions from you? Okay, right. So then thank you very much, and we will meet on tomorrow with the machine learning and the remaining part of the image processing. So thank you very much, and have a good night.